your larger equipment, your refrigerator, so on and so forth, converting to DC is expensive. But you got to keep in mind, we're already using many types of appliances that are already DC. If you look at your little transformers that are plugged into the wall, they're converting AC down to DC, lower voltage type of units, and we're already using that. And
but you are limited pretty much by distance. I mean, you try and run DC over 100 feet.
well, yeah, you need a lot bigger cables. And
No, I mean, you will actually have, when Edison powered Manhattan, they basically had a power generating plant on every single block.
Really?
And they had to run literally a wire from the power generating plant to the light bulb.
Mm-hmm.
I mean, it looked like it was a nest, it looked like a spider web. I mean, it was just, you know, millions and millions of wires going to every single bulb in Manhattan had to be directly connected with a wire to the power plant. And it was very
That's what I tell the students here in the class, that's why the utility companies are running AC, because then they can run small wires as opposed to DC, where they have to run cables as big going down each block.
I mean, if you have 100 light bulbs in your house, you'd have to have 100 wires going in, connected to the power plant.
Yeah, exactly.
And that's why Tesla won out.
Tesla.
So do we actually have one of those like self-replenishing houses, like the non-zero, I think it was called?
Net zero
Net zero,
in New Hampshire?
like in the world.
Yes. There's actually some office buildings that are considered net zero. A lot of people. I'm sitting down with my back to the board. A lot of this gets a little iffy, but there are some buildings that actually recycle their own waste. You know, like human waste. They have these on-site kind of wetlands that recycle all that stuff, and out of the back you're supposed to get clean enough water that you can drink. I don't think a lot of people in those buildings actually drink that water, but arguably you should be able to do that, and so that's how crazy some of these places get. But you can, if you go on the web, it's pretty easy to find buildings that are considered net zero from an energy and a heat standpoint.
If you take recycled water from human waste, isn't it considered much cleaner than stuff you get from tap?
Well, if you put it through the right processes.
Through like osmosis and stuff?
Yeah, there's a lot. Well,
but that's very energy intensive, and it's also very expensive.
Right. It's much better that we just pollute the river, and then we wait a couple miles, and then we take that water out, and we forget that we're actually drinking recycled wastewater. You know, that's okay.
It's a mental thing over a sanitary thing.
The solution to pollution is dilution, is the phrase that people used to use all the time. But yeah, that's right. You can. It's very easy to do that, but it is still very. That's why they use the wetlands approach. You know, you have to have a lot of land to do that, but wetlands are some of the most efficient recycling units that we know of.
You guys are ready to go to college. I spent 2 weeks last summer at WPI, and I was staying in the East Hall, one of their brand new dorms, 1 year old, and it's silver. So it was pretty impressive what they had done. They had like a roof system for collecting water. Everything was environmentally friendly. In the bathrooms, they had, you know, a number 2 and a number 1 flush different, and everything was really cool. So you'll be seeing some of these buildings probably.
Without a doubt. The Portsmouth Library is LEED silver, I believe. The new library of Portsmouth.
I know my sister owns land out in Oregon, and by Bend, Oregon. They're really keen on that off-the-grid type of work out there. She has a place out there, 40 acres or so, that's off the grid. They collect their own water, use cisterns, and that type of thing. The point I'm trying to make is I think as the East Coast, New England area, we're way behind when it comes to energy consumption and renewable resources compared to what they're doing already doing there.
Right. Without a doubt. And the East Coast is headed towards some issues. And you're seeing them in Connecticut. In Connecticut, well, anywhere, particularly in the East Coast. In the West, it's very easy to build something in the West because there's the existing space, and then there's how much space you have to build in. And so when you want to build something else, you just put another square next, and you put it next, and then you go to the next one, and then you go to the next one. And so if you've ever been to Phoenix, which is where I grew up, this is the way Phoenix looks. But now it's filled in this entire block with a whole bunch of other blocks. Every block is the same. Everything is exactly a mile apart in northwest, east, south. And the power lines are all underground, and everything was built because it knew it was going to grow fast. Well, let's go to New England, and now, everything's curvy, there's hills, there's people everywhere. We had to run wires everywhere. Nothing was really planned. Everything's, and you get complexity. And so what is happening in Connecticut is you have all these power grids connected together, right? And you have a power plant here. And this guy is starting to lose some power. And so what do you need to, and there's all kinds of people out here and you're having bad power. You get what's called congestion. And remember how I said that you had to have the pipe a certain thickness to get the energy through? Well, let's say, if you've ever been to Connecticut, let's pick on the World Wrestling, WWE. Their headquarters is in Connecticut. If they build their building here, sure enough, they're going to want power, right? Well, if there's congestion at this point, they need to put in a new line. How is he going to be put in a new line? Not very, because everybody in Connecticut is really rich. And nobody in Connecticut wants to see a power line near them, and nobody in Connecticut wants to see a power plant near them. And so the only way in Connecticut that they can get to do this stuff is they turn to distributed generation. So in Connecticut, this project that we're doing here, it would have cost 50% less, because the state pays for half of everything if you're putting power on the grid, particularly if you're in an area that needs congestion. So if you went down to Connecticut and found a high school near a congested area, you say, hey, I'll put solar panels on your roof. And they're thinking, great, great. But you don't realize that the state is writing a 50% check to get that done, because a power plant costs $1 billion to build. And it's a heck of a lot easier to spend a couple $100,000 at all these other little areas out here to get that amount of power there than to find some place where you can drop $1 billion power plant in the middle of everything. And so Connecticut has these things called congestion areas. And when you have a congestion area, you can build distributed generation projects very easy down there. In fact, ISO, the grid, is one of the, both classes in the morning, actually, I started out with this, and we'll kind of end up with it. So anybody watch 60 Minutes? Last night on 60 Minutes after the game, they talked about hackers. And they were talking about hackers hacking into different things. And the guy who I found to be the most scary was the guy that said that, he was of course the government guy, he said, we think that the biggest problem is hackers breaking into the power grid. And the reason is this: all the other systems like the Department of Defense and all those other people, they have regulations and a lot of, basically a limitless pot of money. When we talk about national security, people don't hesitate at spending money. So if a problem happens, they tighten it up. Utilities are not regulated that carefully by the government. And so a utility network, a computer network, this person's belief was that their systems are easy to hack into. And so people can hack into the grid and just start shutting things down. And the problem is that you've already got a grid that's sensitive because it's not very well planned out and it's not very smart. And then you put on top of it the fact that people can actually hack into it. You've got all kinds of problems going on. So you have this group called the Independent Systems Operator, ISO, and that's who manages the grid. They're this non-profit, non-governmental entity whose sole job is to make sure that power goes everywhere. You can go on ISO's website, and you can actually see some of these places lighting up in the ISO website where they're having capacity problems. And the ISO is the group that has to go tell people to turn on power plants to get power into the grid. And so there's that. The whole point of this is that as that continues to exist, particularly in the East Coast, in New Hampshire we're not really seeing a significant amount of problems, but we saw when the ice storm happened how sensitive we were to weather. Our grid is not very up to date. We have old poles, we have old substations, and we have a lot of growth going on. The idea that more and more distributed generation like solar and wind and combined heat and power and all these things, they are going to continue to get more and more popular, particularly in New Hampshire.